dysfunctional vet here. This is a graphic presentation of me building my first tilt-up windmill. I was in college taking industrial manufacturing and emerging technologies, and I specialized in green energy. For 2 years I lived on solar panels. The last year of that I put up a wind turbine. The photograph that you see is my dog, and I really like this picture to introduce this subject because working with green energy is a lot like having a puppy. You never know what's going to jump up in your face. And by the way, the blurred eyes and all that I saw many a time because he would just come out of nowhere and be in my face. So with that, let's get on and get this production going. In this photograph, you'll notice that I have two solar panels, one on top of each other, and to the right hand side I have a solar panel down in the ground, or on the ground. This is the corner of the building where I'm going to be setting my wind turbine up. If you look very carefully, you can see two cinder blocks, one vertical, one horizontal, and on that is sitting an orange bucket. Very difficult to see against the red color of the shack. However, that is a solar powered air conditioner which worked rather well. This is one of the concrete anchors. It's dug in rather deeply with a post hole digger, and you can see where the eye bolt comes up through it. Now, the proper alignment for the eye bolt should have been in line of the pole, and this one is not. That is a mistake. I lost over 85% of my holding power on it. This is a photograph of the base of the tilt-up tower. Now, if you notice, the concrete pad doesn't show to be very large, and that's because this thing had been in for a while. And what I did was I cleaned off the dirt and put in about a 12-inch pad, if you will, over the larger concrete anchor that went down 2.5 feet. Now, the pieces that comprise the hinge itself were never intended to last for very long, and so those are just straight bar stock. The pipe itself is 2 3/8 inch, or the tubing is 2 3/8 inch oil filled, which I was able to salvage. And you'll notice that there's a strap right there on the left hand side on the brick with some pre-drilled holes. That's going to become part of the saddle, pipe saddle, which you'll see in just a moment. This hinge is not long-term duration. If it was going to be long-term, it would need to be made of very heavy metal. Again, I'm in my last semester of school and I'm getting ready to leave. The black line that you see along the cabin, well, it's not even a cabin, it's a workshop, that is a 1/4 inch water line that goes over to feed the evaporative cooler. The evaporative cooler has a filter element on the inside of it. It has a small solar pump that circulates water, and then it had a 12-volt squirrel cage fan that pulled the air up through the filter element and into the workshop, and it kept it quite cool. In fact, it kept it about 25 degrees cooler than the outside temperature. So if you were running 100, 105 degrees outside, it was a nice 70, 75 degrees inside there. Very pleasant. This is a close-up of the pipe saddle, and let me tell you what you're looking at here. In this case, the pole that seems to be coming out of the sky going down is a very short piece of pipe, and I'm sizing the pipe saddle to fit. The pipe saddle is created from the pipe saddle was created by a collar which I cut to fit the pipe. You can see how it's been cut out. I used a 4-inch angle grinder with a cutter wheel on it to do that. I bored through. Those straps are 1-inch soft steel, and everything was pulled tight. The holes were drilled, and I'll show you some more photos of the actual building of that in just a moment. But that was my short mast, 1/3 the height of the thing, which means it's 10 feet long. My tower is going to be right at 33 feet into the air, and it's going to be slightly above the anemometer that you would have seen in that first picture. And the anemometer, I'll get into detail about it in just a minute. When I actually started putting this section of it together, I forgot to take a picture in the process, but let's go over this real quick. Down at the very bottom, on the extreme right-hand side of the bottom pole, you'll see a bolt coming through. That bolt is what hinges the mast to the hinge that was previously seen. The other bolts that you see there are holding the plywood brace in place. Now the pole that's going straight up vertically has been connected with the pipe saddle that you saw previously onto the mast itself. The upright pole is called a gin pole. It's 1/3 the height of the tower that we're raising, and it's used as a helper to raise the mast. In just a moment you'll be seeing lines that come off at the top of it and tie about halfway up, a little higher than halfway, so that as the gin pole is pulled down, the pole is lifted up without unusual stress. You can see the vices that I use to hold the plywood in place while I put everything together. In this photograph, what we have is you see the ring there with the stainless hardware. That is connected to the gin pole. This other piece that you see with the shackle and the cable, that's a safety guy wire tie-off, and that has to do with just where I was at. I added additional safety to it. Had I been putting this thing up for real, as in long term, one, my hinge at the bottom would have been massively substantial. My anchors would have been all larger, and I wouldn't have needed all this other safety stuff. You'll notice that there's a bolt going through just a little bit above where the eye bolt is going through. That is where the last section of a pole is located, which is actually holding the wind turbine, which we'll be getting to in just a few moments. If you notice, the shackle hardware is all stainless. It's all rated at 1,200 pounds. It's all heavy-duty stuff. There's nothing on here that's light. In this view, you can see the solar panels, and you can also see the gin poles coming up just above the eave of the shop. Now the shop is sitting up a little bit, although it's not real obvious to that fact. There's a full 8-foot ceiling inside the shop, and there's also a 2-foot ridge there on the shop, and that thing is sitting just above. If you look closely, you can see a little shiny spot. That's an eye bolt, and there's one on both sides. There's one, the one that's on the side that you're looking at will come down to the mast, which you can see is on the ground there, and the one on the other side will hook to a come-along, and I'll use that come-along and I'll pull that piece down, and as the gin pole is pulled towards the ground, back towards that utility pole that you see in the background there, the line between the gin pole and the tubing with the wind turbine will then be pulled straight up. That rope that you see right there is where I was testing to see if everything was working prior to actually putting everything together. Again, I'm in school, I'm learning how all this stuff works, and I'm seeing if what I'm learning in school actually does work. Having been in the military for a long time, I learned that going to military schools, you'll learn all kinds of stuff that doesn't work. So I test everything. In this view, I want you to take careful attention to what you have here. You have the pole going up. Now remember, that pole is 2 3/8 inch in diameter. The large ring that you see right there that has the holes drilled through it, and you can see the wire thimble and the saddle clamps in, that is about a 6.5 or 7 inch circular piece of steel that I cut in shop. I don't remember what what it came off of, but I remember cutting it on a lathe. All right, let's go back for just a second. If you look directly above see the blue piece, that's called Smurf. If you look directly above that, you can see a piece of hardware which is, it's kind of out of position, but that is going to be that's going to become one of the guy wires when everything's into place, and it looks really strange the way it's sitting there. I wanted to call your attention to it so you don't think it's something else. The reason that that plastic pipe is called Smurf is because it's blue, just like the Smurfs on TV, and it is a flexible electrical conduit, and you can find it at various places all over the place. Now, if you'll look at those nuts that are holding the eye bolts on that plate, you'll notice that they have wires through them so that they can't back off. You can do the same thing with lock washers and lock nuts, but the standard is still to put a wire through the nut to make sure that it can't back off, or at least to retard it. Now, I want to make a point about something. If you have a wind turbine, the requirement, the IEA 222, it's written in such a way that you're responsible for your tower, but the ANSI standard is to do yearly maintenance on a tower. That's look over the anchors, the guy wires, the hardware, everything. And no part of a wind turbine should be concealed from visual observation. It should be easy to see. And concrete can deteriorate if it's not made correctly, or too much sand, too much gravel, not enough concrete or Portland. And so when I built this tower, I built it to the IEA 222 standard. And again, this was a temporary thing, so I didn't go to a lot of trouble to have everything in line like I pointed out with my anchor. But had this been a long-term project, like for years, I would have done that. The other thing to be aware of is I was in the middle of nowhere, so if that tower collapsed and fell, it was on an area that I was renting, and it wasn't going to do any harm to anything. Granted, I'm in school, and had it come down, that would have given me an opportunity to study the tower failure, and I'll get into that in just a moment too. Here's a good view of that top mast mount with the eye bolts, the wire, the thimbles, and the saddle clamps or the wire saddle clamps in place. As you can see, everything's in place, looking good. I hand drilled these with a 1/16 inch drill, put the wire through, and then went ahead and wired it. My instructor showed me how to properly wire the thing after the fact, not prior to me actually doing this. But there's an actual way that these things are supposed to be wired so that the wire actually hangs on to the thing and doesn't back off. And I would suggest, if you're going to wire nuts on, that you go ahead and learn how to do this. This is a valuable skill to have. Now the tower is upright. You have the ring in place. You can see the guy wires are coming off. They're coming off at 120 degrees. From the radius is on a 120 degree axle. You can see my line coming down from the wind turbine itself. That's that black thing at the top. Then the Smurf to protect the cable, and then it comes back down. You can also see right there, just a little bit above the bottom of the frame, you can see where my wire comes down to my gen pole. Now, this picture doesn't do justice, but the guy wire in the back and the gen pole right there are actually in line with each other, and I don't know why it looks like that, because the anchor for that guy wire in the back and the anchor for the gin pole, which pulled it down, are sitting they're actually all in one pour concrete, separated by about 10 inches of difference. So I don't fully understand why it looks like that, but it does. Also, I want to put a plug in for this tape. I don't know the manufacturer, but I'm almost positive it's 3M. It's UV rated. You see the gray tape on there? It's UV rated, and I called and talked to a charming young lady, and I asked her how many hours of solar radiation would take to break down the UV rating, and she was unable to tell me. Now, this tower is going to be up for right at 365 days. Might be a little bit longer than that. It's going to be in the West Texas sun. It's going to be being beaten on. It's going to go through ice storm, hailstorms. It's going to take a beating. And at the end of 1 year, I could see no deterioration of the tape, and it was almost impossible to get that stuff off of that pipe so that I could throw it away because I had finished school. It was time to move on. I wish I knew specifically what tape I used. Like I said, I think it was 3M. I wish I could give credit to them because that stuff was really, really good. So we'll move on to the next frame. There isn't a lot to say about this photograph right here. What we have is we have the wind turbine on top of the pole. You can see that I've taped it down initially with black electrical tape, and then I'm going to come back over that with the tape that I spoke of earlier. I'm going to go into a lot of analysis on this photograph. The wind turbine is sitting at approximately 33 feet above ground. The anemometer, that's that little white thing which is down kind of low. It's actually a lot higher than it appears in this picture. It's about 1 foot below the blade of the wind turbine. This wind turbine is a low wind start, 3-blade. The blades, when at speed, they turn approximately 340 miles an hour according to the documentation I had on them. It's impossible to see them turn, but they do make a lot of noise. This wind turbine made about 1,200 kilowatts of power for the entire year. The solar panels, now there's 6 of them, they made approximately, according to the instruments that I have, they made 16,800 kilowatts of power. Now, where the wind turbine came in real handy is that normally at night you would get storms, and the storms is when I would use more power, because that's when I'd be listening to a radio or something like that while being in the shop out here, and the wind turbine would produce it. Now, let me get into what's going on here. That wind turbine is a 3-phase power source. The power comes down, it's rectified from AC to DC, and it goes to the batteries. It has to turn at speed for 1 hour to get the 400 watts out of it. That sounds all well and good, but you don't get 400 watts when the thing is turning. You get 400 watts after the thing has been running for 1 hour at speed. So let's look at these panels. The panels, I have 6 of them. They produce 600 watts per hour when they get sunlight on them. And if you have any experience with solar panels, they pretty much produce usable power from a few minutes after the sunlight starts to hit them until a few minutes before the sunlight goes away. Now, as far as having full amperage, let's say it's a 100-watt panel, you may only be getting 50 watts of power, but 50 watts of power is not bad when you're talking 4 to 5 hours of that in the morning and in the afternoon. That wind turbine, on the other hand, has to be at full speed, and it has to run for an hour like that. Winds are variable. Now, if you look right behind where I'm at, there is a pole with wires. Those wires actually took enough energy out of the wind that it greatly affected the wind turbine's ability to run. Also, if you look at my guy wires, they're nice and tight. I guess you can see them. The um, the the tower that I built withstood a 75-mile-an-hour wind, and it came through and it did a lot of damage out there. I'm not going to go into detail, but it withstood the storm. That roof that's on top of the deal is a composite roof. It's tar paper. It's tar with the shingle on it. You roll it out and nail it on. That windstorm tore a lot of that roof off. Not the wood, but the roofing material. I mean, it was a substantial wind. But the tower withstood that, and the generator withstood it. And that during that storm, where I was getting those high winds, they were running 50 plus throughout the night, and then some of those gusts coming through at 75 according to the anemometer. The generator produced good, steady power. Now, the anemometer is sitting on EMT, or electrical metal tubing, or conduit. Like you go into the store, that flimsy tubing stuff that it doesn't bend real easy, but you don't want to build something out of it. Anyway, that was up. That was also part of the test. That was also part of the test to see how the tubing would stand up against this heavier stuff that's got the wind turbine on it. Now, I would never put a wind turbine on anything except rated tubing. And in this case, that tubing that it's sitting on is rated at 54,000 psi. And that wind turbine up there is a little monster. It is trying to get away. It's got a lot of energy and force on it. Rather than belabor this anymore, I'm going to go ahead and sign off, and I'll show you just some pictures of the construction without comment.